All right, so this is the second lesson on scale factor. So before this, we did some practice where we took a Starburst wrapper and we're drawing scale drawings of it, where we said, okay, let's draw this wrapper 3 times as big, so that's a scale factor of 3. Or let's draw it half as big, so a scale factor of a half. Or scale factor of 3 to 2, which is the same as like 3 over 2, or 3 divided by 2, 1.5. So that one was all about like, if you're given the scale factor, how do you now draw it? This lesson is looking at how do you find the scale factor between two different objects. So if you have one thing and like one shape and another shape that's bigger, or like a blueprint in a house, whatever it is, how do you find out what the scale factor was, and how do you tell if they actually are something that's been scaled properly or if they're not? So the first thing we're going to talk about is just some geometry definitions here. There's only two. They're not that bad. Congruent is the first one. Like, if two shapes are congruent, that means that they are like the exact same size. Both their sides and their angles are the exact same size. So if this triangle here was like 2 centimeters long, then this side would have to be 2 centimeters long for them to be congruent. Okay, all the same, each matching side, like this side and this side would have to be the same. This side and this side would have to be the same length, and this side and this side would have to be the same length. As well, all of their angles would have to be the same. Okay, so this angle would have to be the same as that one, and so on. So you can kind of think of this as like, for congruent shapes, I think of this like metal plate. Okay, this here is just a metal ruler, and it does not matter what way I rotate it. Doesn't matter if I flip it over. Okay, however I move this metal ruler, it's still the same object. It's still the same shape, but so yeah, I'm allowed to rotate it. I'm allowed to flip it. That part doesn't matter. So all three of these triangles we would say are congruent in that they are the exact same shape, same measurements, same sides, same angles. Similar shapes we have a little bit more flexibility with. So we'd say two shapes are similar, even if their sides are not the same length, but they have to have all the same angles. So in this case, like this angle matches this angle matches this angle. These ones are all 90 degrees, but they could be different. But for the sides, they don't have to be the exact same, but they have to be proportional. Okay, and that means that all the sides are getting bigger by the same amount. So all the sides need to be twice as big, or all the sides need to be 10 times as big, or half as big, or whatever it is. All the sides have to be being multiplied by that same number. That's our scale factor. So you can think of it like this. This rectangle here, I think of it often like pictures. Okay, so if I'm dragging by the corner here, it's getting like wider and taller at the same rate. Okay, so this would be a similar rectangle. This would be a similar rectangle. But if I only stretch it this way, okay, this is no longer a similar rectangle. Okay, because it's gotten maybe 3 times as wide, but it has not gotten 3 times as tall. Or maybe it got 3 times as wide and twice as tall, but it's stretched, it's been distorted. Okay, so two shapes are going to be similar if they've been stretched evenly. They like all their sides are getting bigger by the same number. They're all being multiplied by the same number. So this, there's kind of a lot of information here. I'm going to zoom in on here to just kind of narrow our focus for a minute. So how do we then find out what the scale factor is? So the scale factor is really easy to calculate. This is like basically the only equation we use in this whole unit on scale factor. Okay, the equation is that your scale factor is equal to the length of one of our new sides divided by the length of one of our original sides, and it has to be like the matching side. So like this side, this is our new shape and our original shape. Our new side here divided by our original side. But it's important that it's like this side and this side, and you're not just like mixing and matching like this side divided by that side. In this case, I mean, these triangles, it looks like all the sides are the same length, so the math wouldn't change, but you can see for like this rectangle up here, how this side and this side, okay, are not a match. Okay, these two are matches. So you can calculate the scale factor by picking any two of these pairs. We could pick our A's, we could pick our B's, We could pick our c's. That part doesn't matter. They're all going to get you the same number. So we could write this as scale factor is equal to the new side divided by the original side, or for short, often I'll just write n divided by o for like new divided by original. The other way that the scale factor is written, we saw this in the last assignment, is when we have a ratio instead of a fraction. But anytime we have one of these ratios, we're basically going to rewrite it as a fraction right away. What's important for you to know is that this one is always the one that goes on top. The first one goes on top, the second one goes on bottom. Okay, and the easy way for me that I remember this is just by it's no. Okay, the scale factor is no, NO. It's always going to be the new one first, the original second, and our fraction kind of goes that same way, like no, down. Okay, so we can always rewrite this scale factor is n divided by o. I will often write this equation as like SF, standing for scale factor, is equal to new divided by original. That's going to be the way I kind of write it for this video. So once we have our scale factor, once we figured it out, then we can use that to like find the lengths of the new shape. So let's do an example here of what I mean. So if I scroll down, so actually in this stuff here, this was just showing us that you can find the scale factor by dividing the pairs of A's or the B's or the C's. All three of those ways would be the exact same. So this example here says, what's the scale factor between the triangles below? So in this case, it's saying like, let's use side B, but we could, or actually it's maybe even a typo. We need to use, if we're going to find the scale factor, we need to find a new side divided by an original side. So I'm going to pick these sides here to be like my pairs of sides. This is my new shape, this is my original, so the new one is going to go on top, and the original one's going to go on bottom. We say scale factor is equal to the new side, which is 20, divided by the old side, which is 5. So that means that my scale factor is 20 divided by 5. My scale factor is equal to 4. So now that I know my scale factor, I can find out what the missing side is here. This one was just labeled with a B. We don't know what that one is. So the way that we do that is we take the original side and we multiply it by the scale factor. Okay, so we'd say, this is what we're doing with our starburst. Okay, we take our original side of 5, and normally you'd have units like centimeters, whatever, but we're going to multiply that by our scale factor of 4. So 5 times 4 gives us the length of our new side, which is 20. Okay, so this one would be 20, which makes sense. I mean, you can tell that one from here, but often you'll be getting different numbers that aren't perfect matches, and so it's not quite as obvious. This one is the same idea, except that our new shape is getting smaller. So we call this a reduction. So if we want to find out our scale factor, it says what's the scale factor between the triangles? We take, same as always, scale factor is equal to the new side divided by the original side. And in this case, I'm going to pick these, actually I'll pick the bottom ones this time. Okay, this is going to be my new side, and this is going to be my original side. So my new side is 1, my original is 5. And so my scale factor is 1/5, okay, 1 over 5. I'm going to rewrite this as a decimal, just because I find that easier to put into my calculator. So to find that, I just say the top number divided by the bottom number, 1 divided by 5, and it ends up being 0.2. So a scale factor of 0.2. So when it now tells me to find the new shape, or this length of this new side here, this side B, I'm going to take the original side and multiply by my scale factor of 0.2, and that will be the length of my new side, which in this case is 1. So for the last example of this video, this one says, are the following shapes similar? Okay, so we said before that similar shapes have to have their sides getting bigger by the same amount. Okay, they have to be stretched equally in terms of like length and height. So how can we do that? Okay, in this one it's not quite as obvious because we're not just saying like 5 and 5. This one has a 5 by 12 and this one's 10 by 30. It's not immediately clear, is this one the same or not? So the way that we do that is we're going to find out what's the scale factor between these two sides. Okay, how much am I multiplying this one by to get this one? This one you can probably see right away, that's going to be 2, but let's actually put it into our formula just to see. So our scale factor is the new divided by the original. So the new is 10 and the original is 5, and so we get our scale factor of 2. So these sides are getting twice as big. But now let's see, are these ones also getting twice as big? And you can probably tell right now that these two are not getting twice as big. The scale factor is the new side, which is 30, divided by the original side, which is 12. And in this case, the scale factor is 2.5. So these two are getting 2.5 times bigger, and this side here is getting 2 times bigger. So because these two are getting stretched by different amounts, like this one's twice as big as 2.5, then we would say that these sides are not similar. Or these two rectangles are not similar. They're being stretched unevenly. Okay, so that's kind of the very basics and of like how to calculate what the scale factor is, and then how do you find what the size of a new one is. And in the next one, we'll get into some more word problems and kind of going back and forth between new and original. So yeah, see you in that one.